Hello, today we will be exploring what is pi, how is it derived, and does it always work. My name is Pedro Parada. I'm making this video for my class Math 241. So what is pi is a question, how is it derived? And so let's see. One way that I know that you can derive pi is by first creating a circle. So we will create a circle with a radius of 1. So kind of similar to a unit circle. And what we're going to do to the circle is we're going to go to the settings and we're going to change its color so we can see clearly what's changing. So we're going to make the circle red. Another thing that we're going to do is we're going to do a line segment, and this line segment is going to be our diameter of the circle. Okay, and we're going to make this diameter a different color because we need to see how it changes. So we're going to make this diameter blue. Okay. So as we can see, if we move B, we see that diameter changes with B as B changes. Right? So what is the relationship, or how do we derive pi? One of the mathematicians that made this a really popular number was Euler, and back in 1737 he started using pi, which was equal to 3.14. Now we're going to see why that is. I've been always interested in this number, one, because it's a really cool number that kind of relates the diameter of a circle to the circumference, and we're going to see how that relation is always true for any circle of any size, and we're going to see if it always works. So the first thing I want to do is divide. Let's divide the, what is it called, the circumference. So you could say circumference of our circle, which is C. Enter, and we get our circumference 1451. Now we're gonna see how long our line segment is. So segment C, segment from point to point, it's gonna go from point C to point D. So let's see what the measurement of the segment is. So to derive pi, we know that there's some relationship between the segment and the circumference of a circle. So let's see. Let's divide A, which is right there. Let's divide it by B, or actually G, because that's the measurement of our segment. Our segment being our diameter, CD. So this is going to give us pi. Now, does this always work for any circle and with any diameter and any circumference? And the answer is it should work. So if we move our B, this makes our circle bigger and our diameter bigger. And as you can see, A, which is our circumference, changes. G, which is our line segment, or also known as our diameter of the circle, also changes to 8.02. So A divided by G gives you pi regardless of what the measurement of these measurements are. So as the circumference goes smaller, segment CD, which is our diameter, also gets smaller. However, our ratio between them is always pi. So this is a great instrument that we used a long time ago and we still use today to measure the area of a circle. We also use it to find volumes of circles, spheres, sorry, not volume of a circle, volume of a sphere, volume of a cone, and also for the volume of a cylinder. Before this, people tried to estimate the area of a circle using, what are these called here? Let's say like a polygon, like a really big size polygon. So they would say like the ratio is from here to here, and it had like a bunch of sides, and they would reduce the the room for error, so they were able to closer and closer get to the actual area of the circle. But it wasn't until this new technology or this new discovery was made that we were able to get the actual area of a circle, and thus the value of a sphere and many other things that were done. So this is one of the things that I always liked pi, because it was part of the unit circle. I never derived it myself, and I never looked at it as much. So it looks pretty cool once you do it on paper. Also, it's really cool how it works with any circle regardless of its shape, of its size. So if it could be a unit circle, 1 of radius 1, diameter 2, and our circumference 6.28, but our ratio of circumference to segment CD, which is our diameter, is always the same, which is pi.